factor the polynomial given that f of k equals 0. This means that this value for k is a 0. We want to find the factors. We're going to use this 0 to set up a synthetic division, writing down the 0 outside the coefficients, and then we should get a remainder of 0. Since x, considering that one of our factors is x minus 2, x divided by x cubed is x squared. So this 1 represents x squared. No x term, subtract 9. Now in order to find our factors, we can stop here, and x cubed minus 2x squared minus 9x plus 18 is equal to x minus 2 times x squared minus 9, and factor one more time x minus 3, x plus 3. Now, when we finish the synthetic division for the next one, we get a factor of x squared minus x minus 3. So we took the polynomial x cubed plus 2x squared minus 6x minus 9. Our 0 was negative 3. Put it into here, write down the coefficients, continue with synthetic division, and we find this one factor, this one quadratic that can't be factored. And so therefore, the factors of x cubed plus 2x squared minus 6x minus 9 are x plus 3, our original factor found from the 0, negative 3, and x squared minus x minus 3. Unless this can be factored, don't try to factor it. And in the next polynomial, again, using our 0 synthetic division, we get a quadratic x squared minus 4x minus 12. This time we can factor it. Our factorization of x cubed minus 8x squared plus 4x plus 48 is x minus 4, x minus 6, x plus 2. Just to clarify, whenever you are writing a factor based on a given 0, remember that this 0 has to make the factor equal to 0. So positive 4 as an input produces 0. Now let's say we have a polynomial and we're not given any zeros. What type of tools and methods can we use to find all the zeros? First, we can put the equation into our calculators and graph, and we can see from the graph that we have 1, 2, 3, 4 real zeros. So we can go through the whole process of using second trace, 0, left bound, and right bound, and guessing. And we are given 1, 0 is negative 3. Now if we continued this, we could find that each additional 0 is an integer. And so we have the 4 zeros, negative 3, negative 2, negative 1, and 1. And therefore, from these zeros, we can actually write the factors. With synthetic division, we saw how we could write the factors from the zeros in factoring. It can be done with all real integer zeros. I know that this polynomial function does not have any other types of zeros because we have 4 zeros here, and it is a degree of 4. Therefore, my function x to the fourth plus 5x cubed plus 5x squared minus 5x minus 6 is also equal to x plus 3, x plus 2, x plus 1, x minus 1. Noticing that for every 0, if it was plugged into each one of the factors, a 0 would make an output of 0, or make the factors equal to 0. So a note about this graph, I actually had to use a window. It's quite small. Negative 2 to 2 for x min and max, and negative 2 to 2 for y min and max. That is because if we use a different window, it would be very difficult to tell the difference between the negative 1.4 and the negative 1. So going through, using the 0 function, we would find that this would have a 0 of negative 1.4, negative 1, and 1.4. Now the problem here is, okay, we can write down all the real zeros, but what if we want the exact form? Because actually, 1.4 was rounded off. You would find that it would be 1.414, and it's actually an irrational 0. So we have irrational zeros here. We want a more exact way to express irrational zeros. So we're going to have to use synthetic division with our 1, 0, negative 1, and get a quadratic that we can actually solve for our irrational zeros. And so we get a quadratic setting it equal to 0 to solve. We get that x squared is equal to 2. Take the square root, and x is plus or minus the square root of 2. Therefore, our zeros are negative 1, plus or minus the square root of 2, and our factors, or x cubed plus x squared minus 2x minus 2, is also equal to x plus 1 and x squared minus 2. For this polynomial, when it's graphed, we can see that it isn't quite symmetric. In fact, when we look at it, it has 2 real zeros, but it's a 4th degree. And the 4th degree with 2 real zeros means that there's actually 2 imaginary zeros. Let's find the zeros using the calculator, and then use synthetic division to find the quadratic. And so using synthetic division, like before, we get a cubic function as a result of our synthetic division with 1, 0. So we're going to actually continue the synthetic division with our other 0 in order to get down to a quadratic. And so our quadratic is x squared plus 4. Now let's solve this. X squared equals negative 4. We can use the square roots method for solving this quadratic, and we get that x is plus or minus 2i. Therefore, our zeros are plus or minus 2i, and our factors of x fourth minus x cubed plus 2x squared minus 4x minus 8 is our x plus 1, x minus 2, and x squared plus 4.